This will be part 2, the final part of the construction of this dual electronic load. I've got one of these 45 by 50, well, I think it's 18 millimeter heat sinks. They're $4.50 on eBay. The first thing I did was drill and tap. Now this isn't the way the fan's going to be mounted. 2 holes for a 440 screw. Then using a transfer punch, which is a carefully selected diameter with a point on the end of it. It's not a center punch, but it fits these holes very snugly. Tiny tap, because we don't want to dull this thing, marks where the other 2 holes get drilled. The fan itself will be mounted like this. Now I've elected to use 440, that is number 4, 40 threads to the inch, screws to fasten this thing in. That's an American thread designation. I'm just more used to working in those units. With the 50 millimeter square fan mounted to the 50 millimeter heatsink, and it's only 45 wide, so there's 2.5 millimeters of overhang on either side. I'm not too worried about that. And don't worry about these screws sticking through. The Arachnid board will fit between the screws. There won't be any interference. Here I've hooked up all 4 fans and one of these modules to this little buck converter, and I'm powering it with the 15-volt wall wart. They've been running overnight, probably 18 hours. I've adjusted the output to 12 volts. It's not uncomfortably hot. I can keep my fingers on it, no problem. But before I actually use one of these, I wanted to test it. Here's a little Arachnid lash up. My power supply reads 20.9 volts out, 20.8 on this meter. Power supply indicates 2.02 amps, and it's fluctuating between 2.02 and 2.01. Now that's clearly 40 watts. The meter has 2 thin red and black wires. They're supplying DC power to the display. And there are 3 thicker wires. And the wire system is, this is the power supply, and this is the Arachnid. It's now 4:45 on a Thursday. I'm just going to leave this setup run. Well, here we are at 4 o'clock on Friday, so it's been almost 24 hours. Everything's fine. I can put my hand on this heatsink. So the little Arachnid device has been dissipating 40 watts or so. The Arachnid, as it comes as a kit, is designed to have the heatsink flush with the top of the circuit board. In fact, the heatsink actually is soldered to two dumb holes in the circuit board and provides some mounting strength. This heatsink has been pre-drilled and tapped for a device. I've elected to install it the other way around so that the Arachnid board sits higher than the bottom. The other thing is, the only thing supporting the Arachnid board are the three leads of the FET. It's not very stable, but I'll show you how we get around that in a little bit. Once you've satisfied yourself that both Arachnids work and both fans work, set the fans in the case and make some black marks that are the limits of the extent of the circuit board and the fans. And then take some of this white silicone stuff. And then just set the fan, the board, and the heatsink on the gooey stuff. Now, I don't think I have enough gooey stuff under the circuit board. Once this silicone sets up, it will secure very well the board in the case. I'll let that set overnight till all the silicone is solidified. You can see how I have mounted the fans on the back. And the next thing I'll do is cut out the cutout template. And I'll drill and cut the front panel. Well, the white stuff is sufficiently set up that they're not moving, and the Arachnid board itself is firmly supported by the white stuff. While I was waiting for it to set, I finished up the front panel. I'll provide a link to a PDF file that will allow you to print the front panel. I've wired up each half like this. The red and black binding posts are here and here, and here and here. I took the red wire from the meter and a red wire from the load and just used the red binding post as a terminal. I took the black wire from the meter and ran it through a 3-pole switch. One of the 3 poles is this one I'm showing here. Another of the 3 poles is on the other half of the load. And the 3rd pole is used to switch the power That way, assuming nothing is wrong, the fans will come on anytime that the switch closes. In other words, without the fans being on, we can't put current through this meter. Now I've got this one hooked to a power supply. The meter on the power supply says 20.9 volts and 2.1 amps. Now these numbers are adjustable. This indicator has a voltage and amperage adjusting potentiometer on the back side. And if I move over to the other one, power supply reads 20.9 and 2.07 amps. Now the wiring looks a little bit messy because I left enough slack so I could take the front and rear panel and lay them down. So when I make them vertical and slide them into grooves, I've got some bunched up wire here. The little regulator board is mounted here, just on the 4 leads. Seems to be supported just fine. It's set for 12 volts output, which supplies 4 fans and 2 meters. I've got a coaxial power jack on the back. What I need to do is, in the top of the case, is drill some holes for heat to escape. Without the holes, this is what it looks like. It's finger safe. This is the load in its final stages. I've drilled, and more importantly, I've deburred, flared, so to speak, the holes. I did a much more thorough job of flaring them on the inside. That's tapering them towards the center, so that the air can enter and exit more easily. These holes, as I have them here, are just smaller than 1/4 of an inch. I'll provide a template for this drilling pattern. The load has been running for about not quite 24 hours. This channel is 42 watts, and this channel actually is at 43, almost 46 watts. There is a significant amount of hot air exiting the top. I hope you have enjoyed this 2-part video series. Please drop me a comment, subscribe, or come back and watch my next video. Thank you.